All right, this video is going to be about inscribed angles in relation to a diameter or a polygon inscribed in a circle. There's two kind of different ways to solve a problem like this. The first one I'm going to show you is how like the your Alex program shows you, and I'm going to show you kind of a shorter cut, I almost think, for the second way, but both will work. Whichever one kind of vibes more with you and you understand it is totally fine with me. Some things to notice here. It says that UV is the diameter. Remember, a diameter cuts a circle directly in half, which means this half the circle equals 180 degrees, and this half the circle equals 180 as well. They give us some additional information here. They tell us that arc VW, so from V to W, is 132 degrees. And that angle V, or WVX, so W to V to X. Okay, so this angle right here is 68 degrees. Okay, and our goal is to find these two angles over here. So what I'm gonna do here is I'm gonna do a little bit of math before we even kind of like dive in here. So what we know is we know that V to W is 132 degrees. Okay, we also know that this half of the circle is half of a circle, so it should equal what? 180. So knowing that, I bet you we could find UV. How do you think we could find UV knowing that this is a semicircle and knowing that this arc over here is 132? Yeah, correct. We're gonna do subtraction. We're gonna do 180 minus 132. And we get 48. So we know that angle is 48 degrees. Good. We can kind of set similar things over here. If we know this angle here is 68 degrees, what type of angle is XVW? You're right, it's an inscribed angle. And how does the inscribed angle relate to its arc? It's half of it. So this angle, 68, is half of this measurement here. All right, so if I want to find out how big this is, guess what I'm going to do that 68? We're going to double it. So what is 68 times 2? It's 136. Okay. Again, we know that this half of the circle is a semicircle, so I bet you now we could find XU. Because what does a semicircle add up to? 180. So I can do 180 minus 136. And get 44 degrees. Now that I have that, I'm actually going to kind of dive into what they actually want us to find here, because I have all of my kind of arcs labeled out here. The first one is UVX. So I'm going to highlight that for us. So U to V, so this line, to X. All right, what type of angle is UVX? Correct, it's an inscribed angle. And how does the inscribed angle relate to its arc? It's half of it. So what should this angle be? 22. Good. All right, up next we've got UWV. So UWV. This looks like another inscribed angle. What is the arc for this angle of UWV? You're right, it's this 48 degrees here. All right, that's what it's like eating or enclosing there. So we're gonna take 48 and we're gonna divide it by 2. Half of 48 is 24. All right, so that takes a little bit more math, all right? It's a little bit more complex. So I'm gonna show you a little bit of a shorter cut that I do. So I'm gonna grab another problem for you. All right, same thing here. We have the diameter of QS here, which means this is half a circle and this is half a circle. We're gonna label what they give us. They give us that the arc of Q to R, this arc right here, is 56. They also give us that QRT. So from Q to R to T. So this little angle right here is 22 degrees. Awesome. All right, so some things that I do, if you notice here, see how there's like a triangle right here, triangle SRQ? Guess what type of triangle that is based on its looks there? It's actually a right triangle where this is a 90-degree angle here. So if this is 90 degrees, if I know that this is 22, is it possible for me to find this other angle? Of course, I can do 90 minus 22 and get this other angle right here, 68 degrees. So that's kind of one shortcut that you can do there to help you find out some angles kind of quicker. And that'll be true for all these types of problems in this unit right there. All right, so let's see what this asks us for. It wants us to find RQS. So R to Q to S. All right, this looks to me like an inscribed angle, all right, which means it's going to be half of its arc. But here's our issue. Do we know what its arc is, R to S? Not right now, but is it possible for us to find what that measurement is? Of course, it's part of this semicircle here, all right, and what does a semicircle add up to? 180. We know from here to here is 56, so what should I do with that 56 and that 180? You're right, I should do some subtraction. If I do 180 minus this 56, I get 124. All right, so this is going to be half of 124. Half of 124 is 62. So this is a 62-degree angle. Up next, we have SRT. All right, S to R to T. Oh, we already found that angle earlier using that 90-degree rule. All right, we already know it's 68 degrees. Awesome. All right, so you can use either method. They're both a little bit lengthier, and I totally understand. So if you get stuck, please let me know.